Okay, so we are looking at drawing a tree diagram to show the different ways to flip a penny, a nickel, dime, and quarter, and then answer the following questions. So we've got 4 coins, so we're going to flip 4 coins. So the first thing we need to do is draw a tree diagram. So this is where we're going to begin. And we're going to flip 2 coins, or flip a penny. And when we flip a penny, we get 2 sides. We get a head and we get a tail. Then we're going to flip the nickel. And when we flip a nickel, we get a head or a tail. And then when we flip the dime, we get a head or a tail. And over here, we would get a head or a tail. And then we're going to flip the quarter. So we get a head or a tail, a head or a tail, a head or a tail, and a head or a tail. So that's if we follow the flipping of the beginning from the heads. Now let's go do the tail part. So if we got a tail, the same thing applies here. We would get our head or a tail on the nickel. And now we're going to flip the dime, and we still get a head or a tail. And we would still get a head or a tail on the quarter, and a head or a tail on the quarter. And then we'll come flip the dime, and we get a head or a tail. We get a head or a tail, and we get a head or a tail. So that's what a tree diagram looks like. You can draw it from the side, you can draw it from top to bottom, either way you want to go. So let's look at all of what we get with these flip coins. So we can get the case where we get a head, 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 head. So we can get all heads. We can get a head, a head, a head, and then a tail. We can get a head, a tail, and a head, or a head, a tail, and a tail. We can get a head, a tail, a head, and a head, or a head, a tail, a head, and a tail. We can get a head, a tail, and a head, tail, tail, tail. Now, let's go to the bottom part. So if we got a tail first, we could get a head, a head, and then a tail, and a head, and a tail, and a tail, and a head, and a tail, and a head, or a tail, a head, a tail, and a tail. We can get a tail, a head, and a head, or a tail, a head, and a tail. Or we can get a tail, and a head, or a tail, and a tail. So those are the possible outcomes that we have from this. From this, we're going to ask a couple of questions. For part A, in how many ways can you get no heads? So if we got no heads, that means we got all tails. There is only one way to get that, and that is if we flipped all tails. For no heads, there's only one way. For part B, in how many ways can you get exactly one tail? Well, we can come up in here and look at our diagram to see how many different ways we get one tail, or we can kind of talk about how we got one tail. So one tail means you have 3 heads and 1 tail, so there's one way. There's another way. We're looking for just one tail. Here is a third way, and then here's the fourth way. So you can kind of figure that out on your own if you struggle with the tree diagram, even though you need to draw it in my class. So if we're getting one tail, that means we're getting 3 heads and 1 tail. Or you could look at you've got 2 heads, a tail, and then a head. Maybe you did 1 head, 1 tail, and then 2 heads. Or you found the head first and then you got 3 heads. So that's where your 4 ways are, if you can't quite see it in the graph there. All right, or in the chart. Part C, we want to know how many ways can you get exactly 3 tails? Well, exactly 3 tails means you're getting 1 head. So it's going to be just like this one, except we're going to have 3 tails and a head, 2 tails, a head, and a tail, a head, and 2 tails, or we're going to get the head first and then do 3 tails. It's still going to be 4 ways. On part D, in how many ways can you get exactly 2 heads? That means you've got 2 heads and 2 tails. So we're going to get a head, a tail, a tail, a head, a tail, a head, a tail. So I just kind of moved 1 tail over. And then a head, a tail, and a head. So I moved the other tail over. See, a tail, a head, a tail, and a head. And then a tail, a head, and a head. And then we also can have a tail on the outside and the 2 heads on the inside. So we have this way and this way. We've got these 2 going the other way. We've got these 2, and there should be 1 more. Let me see. We've got tail, head, 2 tails. Got this one. A head with the 2 tails. Oh, I do have all 6. Okay. I was counting wrong. And so we have 6 ways. So again, you can come up to your tree diagram and the chart you made from that, and you can pull all those out because you're looking for the one with 2 heads and 2 tails. All right. Number 2. Determine the number of possibilities. An 8-sided die is rolled, and then a 20-sided die is rolled. This is using the fundamental counting principle. So we're going to take 8 times 20 and get 160. That's your final answer. You just got to multiply the 2 dice, the amount of sides that they have. All right, part 3, we are calculating each value. So we have 7 minus 3 factorial. That means first thing we got to do is follow PEMDAS. So this is going to be 4 factorial. Remember with factorials, it is going to be every number past it times the top. So 4 times 3 times 2 times 1. You go all the way down to 1. So this will be 4 times 3 times 2 times 1. And when you multiply that out, you will get 24. All right, next part, so that's part A. Part B, we have 12 factorial over 8 factorial, 3 factorial. So with this, we've got some on the top and some on the bottom this time. I'm going to take 12 all the way down to 8 factorial because then I can reduce those. So I've got 12 times 11 times 10 times 9 times 8 factorial over 8 factorial times 3 times 2 times 1. Because that way my factorials will cancel. And once I've canceled those out, I can do the multiplication. So this is 12 times 11 times 10 times 9 over 3 times 2 times 1. When I multiply the top, I will equal 11,880, and on the bottom, 3 times 2 times 1 is 6. And when you divide that out, you get 1980. All right, the next question is finding the number of permutations. When you're finding permutations, you are looking for, you're going to be using those factorials that we just did. So if I'm looking at number 4, part A, I'm looking at 8 objects taken 3 at a time. So the permutations is going to be your N and R. The N is the total number of objects, And the R is how many you take. So it's going to be 8, 3, and it's going to be, for permutations, you're going to use your N right there. And so it's going to be taking out our N here of 8 factorial over our N minus R factorial. So it'll be 8 minus 3 factorial. So simplifying that, we'll get 8 factorial over 5 factorial. And we'll do the same thing we did on the last problem. So 8 times 7 times 6 times 5 factorial over 5 factorial. Those will cancel. And we end up with 8 times 7 times 6, which will get us 336. All right, so for part B, we are given a 12-person board is forming a committee to run the meetings. It will be a 3-member executive board. Oh, sorry, wrong one. The committee will consist of a president, a vice president, and a secretary. And how many ways can the committee be formed? So I look at permutations. They're kind of picky, and that's where it's permutations with picky. So they're picky about who's the president, who's the vice president, and who's the secretary. So when we're looking at this one, it's going to be the permutations, and the number of people that or the board, the number we're looking at is 12, and we're still trying to find a 3-person committee. So the 3 is the same only because that's the same thing that we were given. So this will be 12 factorial over 12 minus 3 factorial, which will get us 12 factorial over 9 factorial. So 12 times 11 times 10 times 9 factorial over 9 factorial. So we have 12 times 11 times 10, and when we multiply that out, we'll get 1320. So those are our answers for that. Now we're going to go look at combinations. For combinations, they're more casual about it. They're not as picky. So when we look at the combinations, we're going to look at problems that are very similar, but they're going to come up with different answers. So the first one we're looking at, so this will be part 5, is we're taking 8 objects, 3 at a time. So it's going to be a combination of 8, 3 this time. So instead of permutations where they're picky, they're more casual about it. So we're going to have less of our answers. It will be a lower number. So the difference is we still have the 8 factorial on the top, and we still have the 8 minus 3 factorial on the bottom. The difference is we have an R factorial right here, so it'll be 3 factorial. So it's the same setup as part A up here, but we have this 3 factorial. Because we have to account for the fact that they're not as picky, they're more casual about it, so we end up with that 3 factorial happening to reduce it down. So we'll end up with 8 factorial over 3 factorial, 5 factorial. 5 is the bigger number, so on the 8, we're going to stop at 5 factorial. And this will still be 3 times 2 times 1 times 5 factorial. So the 5 factorials are going to cancel out. On the top, we have 8 times 7 times 6, which is 336, and 3 times 2 times 1 is 6. You don't have to rewrite it all like I did earlier. I did that so you could see exactly what we were doing. So understand we're still multiplying. Now, notice we got 336 up here, but now we're also dividing by 6. And so we end up with 56 as our answer. All right, let's look at part B. Part B says that the 12-person board is forming a committee to run the meetings. It will be a 3-member executive board. So the difference between them is the permutation had a president, a vice president, and secretary. This one just has a 3-member executive board. They're not picky about who does what. They're just going to be a board. So that's where it's going to be fewer numbers because it's not as particular. So our numbers are still going to be the same. We have a 12-person board. We're still looking for a 3-person committee. So it'll be just like we did before. The difference is that we're going to have that extra number again. So we're going to have 12 minus 3 factorial and also that 3 factorial up front. All right, so 12 factorial over 3 factorial, 9 factorial. We'll stop at 9 again. So 12 times 11 times 10 times 9 factorial over 3 times 2 times 1 times 9 factorial. Our 9 factorials will cancel. Our 12 times 11 times 10 is still 1320. But now we're going to divide by 3 times 2 times 1, which is 6. And when we divide that out, we'll have 220. So with the combination, you're going to have a lower number because of what's happening with the math. All right, let's go look at number 6. Write each set or each event as a set of outcomes. So we roll 2 dice. The total showing is 5. When we're talking about these dice, we're just looking at standard dice that have 6 sides. We need a total showing that is 5. So this will be number 6, part A. We're looking for a total of 5. And if we think about dice, they're 1 through 6. So 1 plus 4 would get me 5. 2 plus 3 would get me 5. Those are the only ways I can get 5. So that's on the first dice. Now this could go the other way because it depends on what you get on each die. So that's where these will repeat. So 1, 4, 2, 3, 3, 2, and 4, 1. That would be the event of rolling 2 dice and getting a particular outcome. Now, if you end up with something like, if this had been like 4, you would have 1 and 3. The 2 and 2, when you roll and you get a 2, 2, that one you would only write 1 time. You're not going to write it twice. You would write it once if it's the same number. But if they're 2 different numbers, you will write them in the reverse order. All right, the next one is we flip 3 coins and obtain more tails than heads. This is very much like we did before. We're flipping 3 coins this time instead of 4. More tails than heads. That means I can get all tails. I can get 2 tails and a head. I can get a tail, a head, and a tail. I can get a head, a tail, and a tail. So there's going to be 4 of them as long as there's more tails than heads. All right, number 7, we are looking at doing some probabilities. So looking at probabilities, if the probability that your CD player breaks before the extended warranty expires is 0.015, what's the probability that the player will not break? So we are looking at, remember, all of your probabilities should add up to be 1. So for part A, you're going to take 1 minus 0.015 and get 0.985, and that's all you're looking for. On part B, if there's a 1 in 4 chance that it will rain for the upcoming picnic, what's the probability that it won't rain? So 1 in 4, that's going to be 1 over 4. So 1 minus 1 over 4 will get us 3/4. And if you need to, you can put it in your calculator. You could make common denominators, however you need to see to subtract those. All right, if a single card is drawn from a standard deck, what's the probability that you will get a spade given that you drew a black card? So for this, we have the probability of a spade given that we drew a black card, because there's only black and red ones. That means we're going to put the number of spades over the number of black cards. So the number of spades in a deck, these are the few things you need to know. There's 52 cards in a deck. There are 4 suits. Each suit has 13 cards. The 4 suits are spades, clubs, diamonds, and hearts. Those are things that you need to know. The black cards are spades and clubs, and the red cards are hearts and diamonds. So if we're talking about the number of spades, it's going to be 13. If we were looking at the number of clubs, it would be 13. The number of diamonds, the number of hearts, they're all going to be 13. Now, this is given that it's a black card. The only ones that work with the black cards are the spades and the clubs, otherwise you would get none. Given that you drew a black card, well, black cards are half of the deck. So half of 52 is 26, or you can look at all the clubs and all the spades make up the black cards, so that's 13 plus 13 is 26. There's many ways you can look at it. You have to reduce the probability would be 1 out of 2. Given that you drew a black card, you have a 1 out of 2 chance of getting a spade. All right, part D, assume that A and B are events. If the probability of A union B equals this, and the probability of A is this, the intersection of the two is this, we need to find the probability of B. So this is understanding that the probability of the union equals the probability of each one minus their intersection. So we are told that the probability of A union B is equal to 0.70. The probability of A is 0.40. We are looking for the probability of B, and the intersection is told to us as 0.25. So I have 0.70. I'm going to combine these two terms because they're similar terms, and I get 0.15. Plus our probability of B. Now I'll subtract that over, and I get 0.55 is equal to the probability of B. You can plug this back in. If you add this together, you get 0.4 plus 0.55. That would be 0.95 minus 0.25 gets you 0.70. So you can completely look at that and see what you're doing. All righty. In an experiment, there are 2 events are given. Determine if the events are independent or dependent and state why. So a penny and nickel are flipped, the tail on the penny, head on the nickel. This is independent because they have nothing to do with each other. You have a penny and a nickel, and when you flip this one, it has nothing to do with this one. If you flip this one, it has nothing to do with that one. So however they land, they are independent of each other. However, if you have 2 balls and randomly select them without replacement, that means you take one out and don't put it back from a dish with red, green, and blue balls, the first ball is red and the second ball is green. So as you have a dish with all of these balls in, when you pull one ball out and you don't put it back, it changes the probability of how many balls are in there and what I'm going to pull next. So if I pull out a red one, and let's say I have 10 balls in the dish. If I pull out a red one, I now only have 9 balls. I'm still looking to pull out a green one, but now it's out of 9, not out of 10, so the probability changed. Without replacement makes a difference, and that makes it dependent, because it depends on what you drew out already to what you're going to draw next. All right, so independent, dependent. And it's all depending on whether or not the first one has anything to do with the second one. And that without replacement is huge on that. All right, number 9. We are given the probabilities and values associated with the 5 outcomes of an experiment. Calculate the expected value. Here's your outcome, here's your probability, here's the value. To find the expected value, we multiply our probability times our value. So we're going to have 0.1 times 4 plus 0.3 times 6 plus 0.4 times negative 2 plus 0.15 times 4. So I took all of these columns and I just multiplied it by that column. This would get you 0.4 plus 1.8 plus a negative 0.8 plus 0.6. And when you add all that together, you will get 2. That's all you have to do on that one. Just multiplying and adding. All right, number 10. Construct a frequency table for the data given. We have the modes of transportation for 20 students in a math course, and we've got to figure out a frequency table. All right, so this is number 10. So the first thing we're looking at is the mode, the frequency, and the relative frequency. So relative just means how it's going to relate. We have a walk, a bike, more like a bike, a car, a skateboard, and a bus. And then we're going to have the totals down here. So those are the different modes of transportation. So we've got walking, biking, skateboarding, and so forth. So what you're going to do is count how many walks there are. So we've got 1, 2, 3, 4, 5, 6 walk. If we count the bikes should also be 6. The car is 5. There's only 1 skateboard and 2 bus. That's the way that they are doing the transportation. Now, if we add these together, you should get a total of 20 because that's how many they said we had. We had 20 students who were walking, riding the bus, doing a skateboard, riding their bike, or taking a car. So you should have a total of 20. This is a way to double check you didn't leave anybody out. Now the relative frequency is 6 over 20, and that'll get you 0.3. This would be 6 over 20, which gets you 0.3. 5 out of 20 will get you 0.25. 1 out of 20 gets you 0.05. And 2 out of 20 is 0.1. So I'm just taking each of these divided by the total number. So 6 out of 20, 5 out of 20, 1 out of 20, and 2 out of 20. Now the other thing that we need to know how to do is create a bar graph for this. Remember, a bar graph does not touch. So the different graphs don't touch each other for a bar graph. So we're going to have our frequency. We're going to do frequency, not relative frequency here. And we've got our mode here. So we've got walk, bike, car, skateboard. I'm going to just put SB for skateboard. And we have a bus. And we go all the way up to 6. So 1, 2, 3, 4, 5, and 6. So for walking, we are all the way up to 6. For the bike, we are all the way up to 6. And I can label this 1, 2, 3, 4, 5, and 6. For the car, we're going to stop at 5. For the skateboard, we are at 1. And for the bus, we are at 2. And then I'm going to just do a little squiggly in them so it's more obvious that those are the graphs. And that's it. All right, number 11, we're going to create some more graphs. So on number 11, represent the 2 sets of data on a combined stem and leaf display. So here's set A, here is set B. I see we have the 20s, the 30s, we've got 40s, here we've got 30s, 20s, teens. So we've got to go from the 10s to the 40s. So 1, 2, 3, 4 is all we need. Now, as you're going to go through here, you're going to look at each of your parts here. So we don't have any 10s here, but we have 29 and we have 22. So it's going to be 22, 29. You only put the number after your 10s place, and you should put them in numerical order. They shouldn't be too hard to do that. So we have 32, 34, 38, 39, and 37. So 32, 34, 37, 38, and 39. On the 40s, we have 42, 43, 43, and 47. On the other set of numbers, we have 13, and we have 16, and we have 20, 21, 21, 22, 26, and 28. We have 32, 38, and 39, and we don't have any 40s, so we would be done. That's all you got to do for that one. All right, for part B, we are looking to create a 5-number summary for the distribution and draw a box and whisker plot. So we are given a bunch of numbers. The first thing I'm going to do is put them in order. So we have 15, 18, 18, 21, 23, 24, 26, 31, 41, 44, and 45. So the first thing I did is take all of the numbers and put them in numerical order. Now, to find the 5-number summary, we've got to find some medians. Remember, the median is the middle number, just like in the middle of the highway. We have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So halfway between them is going to be the 6th number. 1, 2, 3, 4, 5, 6 means I have 5 on this side and 5 on that side. So this will be my median. Now I need to take the median of both sides. So I've got 1, 2, here's our middle number. So this is going to be referred to as quartile 1. There's 2 on either side of it. You don't count this one when doing the median at this side. And this one will be our minimum number. We'll do the same thing on the other side. Our median is going to be the 41. That is going to be called quartile 3. And our last number will be our max. You really need to put it in numerical order or it's going to be hard to do this. Once you've done this, now you need to draw a box and whiskers. So I'm going to start down here at 15. I need to go up to 45. I'm going to do it in increments of 5. I'm going to make little hash marks so then I can draw my big ones. So I've got 15. Let's go with 20, 25, 30, 35, 40, and 45. 15, 20, 25, 30, 35, 40, 45. So I know this one here is going to be 45. This is my max. This is my min. All right, so my quartile 1 is at 18. So this is 20. So 18 is going to be about right here. And I'm going to label it as 18. My median is 24. This is 20, so 24 will land about right here. And 41 is going to be down here at this point. And then I'm going to combine my boxes. Label this as quartile 1, quartile 3, and my median. And that's your box and whiskers. I drew an extra part of the line. It doesn't matter as long as you've got it where you can see that this is your whiskers, this is where it ends. All righty. Next problem we are going to look at is looking at the range, the median, and the mode for the following distributions. So let's look at number 12. For 12, we're looking at the numbers of 5, 7, 3, 8, 6, 5, and 9. To find my range, that's the range of numbers I have. I need to take the high one minus the low one. So that's 9 minus 3 is 6. The mode is the number that happens the most. The only number I have that repeats up here is 5, so my mode will be 5. And the median, I have to put them in numerical order. So we have 3, 5, 5, 6, 7, 8, and 9. I have 1, 2, 3, 4, 5, 6, 7 numbers. So 1, 2, 3, the fourth number will leave me with 3 on either side. So that will be 6. All right, number 13. For number 13, we're going to find the mean and standard deviation for the following. So we have our numbers here. I've kind of set up the box already, so we've got all the numbers here. We need to find x bar. So to find our x bar, we need to add all of our numbers up and divide by the number of numbers we have. So that's going to be 2 plus 12 plus 3 plus 11 plus 14 plus 5 plus 8 plus 9. When I add all those together, we're going to get 64. I have 1, 2, 3, 4, 5, 6, 7, 8. And you can double count your numbers over here. Make sure you didn't leave one off. So I'm going to divide by 8 of them. And 64 divided by 8 will get us 8. So now I'm looking at taking my x minus my x bar. So we've got 2 minus 8 will get us negative 6. 12 minus 8 is 4. 3 minus 8 is negative 5. 11 minus 8 is 3. 14 minus 8 is 6. 5 minus 8 is negative 3. 8 minus 8 will be 0. 9 minus 8 is 1. So now we have negative 6 squared, which will be 36. 4 squared is 16. Negative 5 squared is 25. 3 squared is 9. 6 squared is 36. Negative 3 squared is 9. 0 squared is 0. And 1 squared is 1. When I add all of these numbers up, I will get 132. So now, going to our standard deviation formula, remember that the standard deviation is equal to the square root of the summation of x minus x bar squared all over n minus 1. So when I'm looking for that, I've already found the summation right there. My n is the number of elements I had. So this will be the square root of 132 over 8 minus 1, square root of 132 over 7, and that's going to be 4.34. All right, so now we need to find the following in relation to z-scores, and I forgot my z-score chart. So in following that, you need to get the z-score. I'll have it on the table. And we're going from 0 to 1.23. So on your z-score chart, you will come down this side and go 1.2, and on the top you go 0.03. And where they match is where you're going to find that value. So between that, when you take your 1.2 and 0.03 from the top, you will find that you get 0.3907, which is 39.07%, because you're looking for percent. That's part A. For part B, you are looking for the formula of z is equal to x minus mu over sigma, and you're just plugging in the values. We're told that x is 87 minus our mu, which is our given mean, which is 80, over our standard deviation, which is this type of sigma, it's a lowercase one, over 5. So that'll get you 7 over 5, which will be 1.4. And those would be the last two problems.